program. Great, thank you. So first, I'll just give a quick overview of our organization in general, Zero FoodPrint. We're a nonprofit which works to change the way we grow food in order to restore the climate. And so the organization was actually originally founded by restaurateurs who wanted to really engage their industry to take climate action. And so Zero FoodPrint was created in an effort to make it easy for people who end up eating the food to be able to make a real difference in our food system. And so we raise funds from member businesses, individuals, and philanthropy. And then we redistribute that to farmers and ranchers through grants. So we have member businesses all around Colorado. Many of them are restaurants, but we also have wineries and bakeries. We have a few composting companies, a museum even. So really any type of business can participate, and they essentially contribute a portion of sales, typically 1%, and then we have a competitive grant program to award farmers and ranchers, which is what we're talking about today. But I'll just quickly say this is also a really grassroots movement, so if you know of any businesses that could be interested in joining, we're all ears. We're always looking to expand our impact. So I guess I'll say, since we're a climate organization above all and a food and climate-based organization, our grant is really primarily looking for climate impact on farms that produce food for human consumption. So when you apply for the grants, you can apply for up to $25,000 to implement anywhere from 1 to 4 climate smart farming practices of your choosing. So we use the NRCS's definitions of conservation practices, and there's a list of approved practices on our website. But just to give you an idea, it's things like hedgerow establishments, prescribed grazing, cover cropping, no-till or reduced till, things like that. And then once you know the scope of work that you want to carry out, you use this online carbon sequestration modeling tool that we provide in the application. And that is what gives us this estimate of the carbon that would be sequestered of implementing these practices on your land. And then we use that to sort of rank applications based on cost effectiveness. So what projects have the most carbon sequestration compared to their grant bid. There's a few other things that go into it, of course, but that's really, I'd say, at the core of what makes a project competitive is the cost per ton of carbon that the project is expected to sequester. So we also do require that you work with a technical assistance provider that will essentially just sign off at the end that everything has been completed appropriately. Zero FoodPrint covers the cost of technical assistance. It's just, we ask that you identify who would be your technical service provider and include a quote from them as part of the application. But that's, once you have your scope identified, what you want to apply for, and your technical service provider, we really have tried to keep the application very simple and can be filled out in a matter of 15 or 20 minutes. So the deadline for this round is October 20th, and we're hosting a full webinar this Friday with more information on all of this and plenty of time for Q&A. So that's at 3 p.m. Mountain Time on the 29th. So we'll include a link to the Eventbrite, I'm sure, in the chat. And yeah, I'd really encourage you all to take a look at the application, start sort of playing around with it. And that way, you can really use that time really effectively to get your questions answered. So but then, of course, if there's anything, questions you have between now and then, you're always welcome to reach out to us at grants@zerofoodprint.org.
Great. Thank you, Alana. And I will include a link in the chat box here. And I encourage everyone interested to go to that webinar, attend that webinar. You'll find out a lot more. All right. First up, we're going to have Clinton Sanders talk about compost. He is with the Colorado Compost Council. He's got some slides for us and is going to go ahead, Clinton.
All right. Thank you, John. Really appreciate it. Let me just go. Does that look good? Yep. Okay, good. Great. Hi, everybody. Yeah, my name is Clinton Sander. I'm actually the marketing manager for A1 Organics, but I'm here representing the Colorado Compost Council, which I'm also on the leadership team for. And the Colorado Composting Council is a state partner where we are part of the United States Composting Council. Right there, that QR code is a great link to connect with us, just so you guys know. But I'm gonna give us a quick little refresher on how amazing compost is. As you can tell, that is my world. But yeah, guys, with the Colorado soil health fundamentals and the soil management principles, strive for biodiversity and maintain living roots. Compost aligns really well with a lot of these best practices. And I mean, just the simple power of compost is incredible. I'm going to jump on a couple of them, but just as you can see here in this list, we're talking about a lot of great things when it comes to moisture infiltration and permeability, talking about holding capacities within light soils, reducing water loss, nutrient leaching, improving moisture retention, supplies beneficial microorganisms to the soils and growing media, encourages vigorous root growth, enables soils to retain nutrients longer, buffering soil pH, improves disease suppression. Compost is incredible. It is really incredible stuff. One thing I'm going to just focus on a couple things that are very important to Colorado soils. So organic matter. A lot of us have been talking about organic matter and within these healthy soil practices. So 25 to 35% per cubic yard is organic matter in Colorado compost. Why is organic matter so beneficial? 1% of organic matter in the top 6 inches of soil would hold approximately 27,000 gallons of water per acre. We need to restore and maintain our water here in Colorado. Applying compost is a faster way to get this organic matter back into the soil. It's going to take time and take seasons, but again, we know it's been proven time and time again. There's the NRCS right there. The beneficial use of organic matter in our soils. Again, another one where this is actually local here in Colorado. We're talking about, again, each 1% increase of organic matter in your soil is going to retain an additional amount of water per. This graph right here, guys, is just in gallons per 1,000 square feet. So we're estimating about 620 gallons per 1%. 1240 per 2%, and it continually goes up, and we can retain more water, use less. Compost is incredible. I've always said, once everybody realizes how incredible gold compost really is, we'll never be able to make enough. It's just not going to happen.
Hey, Clinton.
Yeah.
I'm not sure if it's for everybody else, but on my screen, your slides aren't changing. I'm still seeing the.
Oh, shoot.
I'm having a similar thing happen, but I thought it was just froze up.
Okay, you should be seeing compost, apply a big pile of compost on some grassland.
We see the home page, the first slide.
Oh no. Sorry, people, for technical difficulties. It's moving on my end. Let's see here, Shawn. Let me see if I can fix this real quick. Cannot.
If it makes any difference, we're just seeing a PDF. You might not be sharing your actual slideshow.
Okay, here, I'm gonna try this. Hold on a second here. How about now?
Now we can see it.
We're good? All right. And I just want to, since Zero FoodPrint is on the phone right now, that compost application there on the left is actually through the Zero FoodPrint program. And that was one of the first years where we were doing compost application to some local agriculture in the Boulder County area, which is fantastic. So again, guys, yeah, talking about organic matter, how does it retain? How does it save water? It does. It's incredible. The second thing I just want to really touch on, guys, is like what's in it. Like, why is compost so beneficial? When we're talking about strive for biodiversity, compost really is and has a high level of microbial activity. It's a happy place for the microbes, fungi, hyphae, soil web, etc. You know, a lot of times you've heard this statistic, but it really is true. 1 cup of healthy soil that contains 200 billion bacteria, 20 million protozoa, and the list goes on. Having this live microbiology back into your soil, extremely important. Compost application is a great way to support that and to get the biology back in. I'm gonna move, hopefully this is working. Are we still seeing everything good? Okay.
Yes.
Okay, another thing I want to touch on, guys, that's really important, and it's part of the Colorado Composting Council and USCC Composting Council, is the STA Certified Compost Program. This is a program that compost manufacturers pay to be a part of. It requires us to, depending on volume, to test all of our manufactured compost, either monthly or quarterly, and it provides a compost technical data sheet back to you that has over 14 parameters that allows you to line up your compost to depending on what your soil test is coming back to. It's a great tool and information. It sets compost aside from other non-tested compost. So as you're thinking through, if you're going to be using compost, make sure that you're getting a certified compost, a tested compost, so that you can see what's going on, what's happening. I missed a slide. I don't know. Oh, there it is. Again, sorry for the technical difficulties, guys. I apologize. But again, here's part of the STA certified compost. It's basically a Carfax for your compost. You know, it's providing the clarity, the consistency, and the confidence within your compost. So very important. I'm going to put a link in the chat that actually will take you to the USCC Composting Council that has a web page that will show all the compost manufacturers across the country that are a part of the STA program. But again, it's really important to make sure your compost is tested, know what's in there, make sure that there's no pathogens, etc. Last picture, and then I'm going to move on because I know I only got 5 minutes. But here's a great example of the benefits and the strength of compost. This is a simple strip of top-dressed compost across a tee box that happened in November. The following year, the sprinkler has not been turned on. This is March the following year. Nothing has happened. But as you can see, the grass is healthier, it's greening up quicker. And it's amazing what a little bit of compost and how beneficial it can be. So I love that photo. It's one of my favorite. So thank you, everybody. I'll put my email in the chat as well in case anybody has any questions.
Great, thank you, Clinton. We are having multiple types of failures of technology today.
Oh, no.
Christine Newton's computer has crashed and is restarting, so she is going to be moved back toward the end of the agenda, and instead Patrick O'Neill will be speaking next. Patrick is with Soil Health Services, and hopefully he's able to present to us.
One moment. And can you see a title page?
Yes.
We can.
Great. Let's see if I can get this to run. All right, my name is Patrick O'Neill. I'm an agronomist and a soil scientist, and I also serve as a supervisor on the Soil and Water Conservation District named Mosca Hooper Conservation District. And several years ago, we set down the path of trying to find compost materials that may be distinct and have a unique ability to do something more than what we've seen in other compost materials. I had seen, just for some reference, where I live is in the San Luis Valley here in South Central Colorado, and I split my time between the San Luis Valley professionally working as a consulting agronomist with farmers in that region, and in the Uncompahgre Valley working with farmers there on the western slope. So the some background, the Clinton had talked about the life in the soil. Dr. Elaine Ingham was one of the early people in the soil health community to describe what's referred to as a soil food web, and the many different interactions that these organisms have, one with another and with the material that we call soil, and their influence on nutrient cycling, on water holding capacity, on the health of plants and productivity. Further, she described, and others have described this as well, a phenomena where highly productive ecosystems tend to be ecosystems that are relatively stable, and those soils typically develop into a fungal rich or fungal dominated state relative to the number of organisms of bacteria, or rather the biomass of bacteria in those soils. So the slide in the lower right is a successional slide looking at different plant biomes and then their associated fungal to bacterial ratios. You'll see the most productive are the ones with the highest fungal to bacterial. And this was intriguing. I learned about this in the early 2000s. However, putting it into practice, it was consistently a challenge. So far, so good on the slides. You can see this with a man's head stuck in a hay pile. Is that correct?
Yes.
Great. Okay, so from around the year 2000, thereabouts, up until about 2018, hunting for a compost that would do everything that we would hope a compost could do had been like searching for a needle in the haystack. We had the inspiration of folks like Dr. Elaine Ingham telling us the world of possibilities that existed with the use of diverse compost materials and compost extracts and compost teas. However, sourcing and finding for purchase or to make these materials proved incredibly elusive. And in the instance of the San Luis Valley, for instance, we experienced lots of failures between the year 2000 and 2015 with compost and compost extra and compost teas that up to that point we weren't able to describe why they had failed, why they weren't working as we expected them to. And it was really a frustrating experience. At the same time, we were living through incredible droughts, the likes of which we hadn't experienced in living memory, and having to reduce irrigated acres because we just didn't have the water to support them. So we're living with this promise of compost, or the materials that relate to compost, as being a saving grace, but we weren't seeing the real benefits in our attempts. At the same time, a friend of mine named Kirk Thompson, who was an agricultural engineer, since passed, working for agroengineering, did a study within the San Luis Valley looking at an intensive use of compost for our region. So in our region, we have compost that sells for $75 an acre, or sorry, $75 a ton when applied. So that would be, for this purpose, 3 tons per acre, $225 an acre on irrigated cropland is what people would be investing when they put on a relatively modest, in the compost world, a modest amount of compost per acre, but on a crop budget, that's a huge investment annually for most crops of $225 an acre. So he looked at where we were integrating this turn type compost 3 tons per acre per year on an annual basis, along with cover crops in a potato rotation, and tracked that over the span of 3 years, and looked at what was the impact on parameters of soil health. And what he discovered, much to our dismay, was it was really hard to tell that anything happened when we put compost into the system. And this, again, was in the span of 2015 to 2018. So we were investing all of this money and time and effort into getting compost applied and integrating it in the hopes of building soil health or building productivity, fertility, water holding capacity. And we were spinning our wheels. And so that was an outcome that was really challenging to hear and to digest. At the same time, during that same period, myself and many others became aware of the work of Dr. David Johnson, who is based in southern New Mexico, and we became intrigued by the story or the account that he was relaying of a particular kind of compost that he had developed together with his wife, Wei Chen Su, that looked, I'll go back a slide, that was not looking at tons of material per acre of application, but rather pounds of material per acre. And it was a very distinct, different kind of compost that he was describing. It was something that was very fungal rich. And that piqued my interest because that was something that 20 years before Dr. Elaine Ingham had been talking about and beating the drum loudly, that was what we were seeking, to move our systems to some sort of higher level of fungal biomass, fungal activity. And I was interested. So these are a few slides that I borrowed from Dr. Johnson's slide deck at his permission, looking at biomass of plants, and then looking at the media or the soil that supported them. And he didn't find strong correlations of productivity with any of the NPK or organic matter that we may have assumed would have lined up, but he did find where he tested fungal to bacterial ratios in these growth medias that they did line up pretty well. Where higher the fungal content relative to bacteria, the more productive those plants or those systems. And that again was reaffirmation of what we'd seen some 20 years back in that description of Dr. Elaine Ingham. So this was what led us at the Conservation District to think maybe there's something to what this man's describing. And so again, just some additional background information on what he was attempting. So effectively 450 kilograms per hectare, 400 pounds per acre was the compost application rate of a material that was developed in these vessels right here. And the material was loaded in. The pipes in the middle are for passive aeration. They are pulled, leaving a vacant chimney that allows passive aeration. And then they're kept in a high moisture state for the span of a year while they do their thing, turning into compost. And so here we see some, again, slides from Dr. David Johnson showing where he used this 400 pound per acre rate of compost on ground together with cover crops integrated, and the progression of those carbon stains. On the bottom of the screen, you see the 3-inch, 7-inch comparison. That's where the 7 inches is where the compost had been integrated into an irrigated cropland scenario. So I'm going to fast forward, because we only have a short time today, to what we did back in the San Luis Valley. So we took all these ideas from Dr. Johnson and rallied a bunch of the farmers in our region, and also one farmer from the Uncompahgre Valley, and said, hey, we got this crazy idea. Maybe if we made a compost that could turn into a high fungal compost, we would be able to use a small amount, relatively small amount compared to turn compost, and get a big benefit. And hopefully that benefit would be lasting, not just a one and done or a flash in the pan type of scenario. And so we found interest from a commercial compost maker who was game to try this out. but on a very big scale. And so he modified the original design of a small vessel into a very large building facility where the compost could be attempted. We did that from 2018 through 2020, and found that this material turned into what we had hoped, a very fungal rich compost. And it's a vermicompost, as after the heating phase, the thermophilic phase early on, there are composting worms introduced. And this is one of the results of our testing, looking to see, did we achieve something different than what we got earlier with churn composts? And in fact, we did. We had a very large amount of fungi that developed relative to bacteria compared to our very, very bacterial churn composts. And what did it all mean in the end? We took it to the field in the San Luis Valley and in the Uncompahgre Valley on irrigated croplands and on irrigated pastures, and began testing. Our testing rate was the same as what Dr. Johnson had started out with, 400 pounds per acre. And what we found was within year one, most of these systems responded very well with higher productivity, increased water use efficiency, increased carbon at depth. These were things we were hopeful to see, and it turned out with testing we found. And what we found, this was a picture from 2020, with just a one-time one-time application of compost of 400 pounds per acre. Tracking over time, what we found was the more tillage these systems involved, the less cover cropping they involved, the less time with green growing plants, the quicker they came back to whatever steady state they had been previous to the application. And so it's to say we have a unique opportunity to build soil health, if we manage accordingly after these large interventions or these large investments or these larger investments. Since then, we've got farmers, including one with the Zero Footprint project, who's attempted to do the same with 100 pounds per acre of this material to see if the signal remains and does the same thing. This is some of the initial testing we've done, just evaluating yields and structure and carbon at depth. Beyond that, we've taken the same material and run it through an extractor that the conservation district sourced or purchased, and for the purpose of taking an even smaller amount of compost, a matter of 10 pounds per acre or thereabouts, and running it through a water bath very quickly and washing these soluble materials that are in the compost into this water bath, and then carrying that material to the field. We've got partners in CSU range extension who have evaluated this on the eastern side of Colorado in some small plot trials and found some promising early results. What we get from a compost extract that we don't get from a bulk or that is unique from, say, a compost tea. Compost extract is just like a quick water wash. You're just washing out whatever's going to wash out, and the purpose of that is to carry out whatever is in that into the field, and then leave it to the plants and the microbes that are in that field to sort out what's going to be useful and what's not. So it's a lot of we don't really know what to expect out of it. It'll be totally dependent on the quality of the compost that you start out with as to what will wash out of it. We're using a fungal rich vermicompost and think that that's giving us the result in the biostimulant result: increased growth, increased carbon accretions, increased rhizosheath development on plants. So these are all the things that we anticipate. We do expect that when we use this very low rate of compost effectively per acre or in a compost extract, we're getting a transient effect. So something that's going to last year after year after year, but something that will support the growth of that crop that year and maybe have a signal beyond 1 year, but not expecting a lot out of it. So that's the extent of my slideshow. What I will say is the Star Plus participants who've been using this, some have applied this to a cost share component, and some have just said, we like the idea, we like the notion, we've tried it, we like it, we see results down to the line where it's been applied. And so they have lined up with the commercial composter who supplies this material and said, we're going to make our own extract, or we're going to buy extract from you, and applied it themselves. Whether this could be cost shared on a CDA Star Plus contract in the future, we'll hear more about that. But even if it's not cost shared at some point, or if the cost share opportunity is used for things like cover crop seed, we see many farmers in our area gravitating towards this because of the benefits that they see just with their own eyes, and say whether or not if it's on a cost share list, it works for us and we'll do it anyway. So I'm happy to field questions at some point if there's time. Otherwise, I'll drop my email in the chat and you can follow up with me afterwards. Thank you.
Thank you, Patrick. Great information. All right. Next up, we have Shawn Bruckman. Shawn is with The Ground Up and also has many other accolades that I could probably bring up, but I bet she could do a better job. So here's Shawn. She's going to talk about her work across the state, and she is from Eagle County Conservation District. So take it away.
Hi, thank you. So let's see, is my slideshow showing?
It is.
And did it just change?
It did.
Okay, cool. So, yeah, I'm Shawn Bruckman, and I'm in Eagle County. I'm on the board for my conservation district. I'm on the Soil Health Advisory Committee for the STAR program, and I am super passionate about soil and soil health and soil biology. I have a company that does really similar things to what Patrick is doing, and we're finding really similar information. So, as Clinton explained, compost is so beneficial. And as everyone on this call already knows how beneficial compost is for the physical, biological, and chemical components of soil. And I just wanted to show you some pictures of how we're seeing that in the field in Colorado and what we're doing. So, almost everything on here is from things that we've been doing with compost and compost extract. And you can see these mushrooms here were grown in a field that we were doing some extract on. I did some experiments with biochar and inoculating the biochar with compost tea. And so that we're still in the process of looking all of those results, but this is a field where we've inoculated with biochar, and it's really obvious the benefits. So we focus on the soil food web, just like Patrick was talking about. And when it comes to STAR, you have the basic soil tests that you run, and that's great. And I also would really encourage that you go further than that, because I think that looking at being able to identify the different classes of microorganisms in the soil is more beneficial and helps you to be able to target what you want to do than just the simple respiration test. So I think the respiration is important, and knowing that there is life in the soil is important. But just going back to what Patrick's saying, life in the soil as bacteria versus life in the soil as fungus and nematodes and these higher level trophic level organisms is very different. So we do direct observation microscopy, and you can see in this slide, this fungus, the fungal strands at the top, is coming directly out of our compost extract. So we are testing our extracts and the compost going in on a pretty much weekly, bi-weekly basis. There's little microarthropods, which are really important in the soil food web, and cycling nutrients and eating the bacteria and getting those nutrients available. And then on the bottom right, you can see a beneficial nematode. And we know that this is beneficial because we can see the mouth parts of that nematode and see that its job is to eat bacteria. It's not to invade the plant roots. It's not to be a parasite on the plant, but actually eat the bacteria and cycle those nutrients and make them available to the plants. So what we're finding is the aggregate stability in the soils that we're putting compost and compost tea on. And I guess I also want to say that I think doing a combination of compost and compost extract is where I'm finding the best results, because the compost helps with that structural component, and the extract then is what comes in and populates the home that the compost provides. So I think that when you're starting with the compost, any compost on there that's full of organic matter, any compost that's been STA tested and gone through the processes to further reduce pathogens, is going to be key in helping with the structural components of the soil, and then using that as a home to get this extract on. And as Patrick was saying, you can get that plethora of life out there in a small amount, in just gallons of material rather than lots and lots of yards. So going in and getting the compost in the soil and then supplementing through the years, because after you till it that one time, you don't want to come back and till it again. That'll just ruin all that fungal life. So we're finding aggregate stability is better in some of the improving in areas that we're working with. Water holding capacity. A lot of you have probably seen these rainfall simulators, and this picture on the right is area that was it was completely weeds and just compacted soil that we actually scraped off all the topsoil to get the weeds off, and then came back in with a compost topsoil mix, and then planted seed directly into that, and have been supplementing with compost tea about 3 times a year. And you can see in the little buckets underneath that there is no water. I don't know if you can tell that there is no water that came through on the erosion side of runoff that came out of there. It all went through, and it was all filtered through the soil. So the ability of that soil to filter and hold and move the water through was super obvious in this demonstration. We just did this a couple weeks ago. We're also, you can see in the plants over time, the nutrient availability, or I guess the plant's response to showing us that there is a deficiency in nutrients is changing in the areas that we're putting the tea on. This particular picture is the biochar project, where there's biochar in the soil, and then we're inoculating a couple times a year with the compost tea. This was just after the first year, so 2 applications. You can see the control still had a lot of chlorosis. This is alfalfa. And the area where we were putting 15 gallons an acre was just green and lush, and just walking in the field. The proof is in the pudding. The proof is in the tea, and in the compost. It's really apparent, and that's what we're hearing from the farmers and ranchers, which I think is the most impactful, is when you have the producers coming back and saying, wow, I can really see it. It's in the first year, and them to be able to give that testimony. So I also wanted to show how to get the compost out there, because with the STAR grants, the question is, and your job as technical assistance providers is to help advise on what people can do to implement these practices. So I just wanted to show in action using manure spreaders. There's all different kinds of manure spreaders on the market. lots of people have them already at their disposal, and if they don't, their neighbors might. And so you might be able to get like an equipment share going in your district or in your area. And so it can be as large as a large spreader, or a one of the smaller spreaders that goes behind the tractor. It could even be a hand push spreader if it's a smaller area, probably not the 65 acres that we're doing in Star, but if there's smaller acreage. And then you can also get more of a localized, if you're doing like a row crop, to get that compost in there and target it to the area you want to get it to. And then we're doing a lot of compost on already established areas. So some of these pictures of the equipment came from the compost uses manual from the US Compost Council. So putting these spreaders out there to get near the base of the tree, not on the tree. And then you could also do the hand method of actually getting out there, spreading it around and raking it. So getting it in the root zone under the drip line is crucial for that tree area. And you're not going to be able to work it into the soil in an established area. So just getting it on top of the soil. And this top right is in Palisade, a project that we're working on. And already we're still in the first year, so we don't have all of our results yet, but just this is Mesa Magic compost, and just getting that compost out there, and the test that we've done in the field with the infiltration test, already you can see that the infiltration is better in the area where the compost has been applied. So if nothing else, and just water saving potential is all the reason to do it and get it out there. And then getting to that extract, the liquid application, there's a few different ways to get it out there. You can do foliar applications with a hose, a small boom sprayer on the back of a four-wheeler or a side-by-side or a tractor. Getting it directly into the flood systems. We've had people put it right into their flood canals and into their gated pipe areas. And then putting it right through the irrigation boom sprayers. So this is down in Fruta, and we just put filled the cistern, his watering cistern, with a compost extract, and then he got it out super efficient onto his land. A great way, doesn't involve any trucks driving over the land. He had already incorporated biochar and compost into this land at the beginning of this season, I believe. So now our goal is to minimize that disturbance, because we want that fungal life to grow. And so inoculating all of that great structure in there with the biology from the extract is our next goal. So that is.
We do have one question.
Yeah.
What lab would you recommend for microbial analysis?
Oh, well, I would recommend me. I think Patrick does it too. So I would look up the Soil Food Web Laboratory website, and there's probably a Soil Food Web technician. There's a few of them in Colorado. So the most challenging part or I guess the most expensive part of getting that done is the overnight shipping. So Dr. Elaine Ingham has created this system to train and certify technicians all over the country, so that you don't have to send it to like New York or Oregon, which was where the original Soil Food Web Labs were, and that you can probably find somebody in your area who can quantify and delineate the different species or the different types of functional groups of organisms in your soil. And Patrick, can you say, do you do that as well in your area?
No, I don't. I
Okay.
don't do the microbial testing for soils, but I would suggest looking for a lab that can distinguish fungi from bacteria as a starting point, and give you a sense of microbial biomass. That seems to be very useful from what I've seen.
Yeah, I agree with that. Yep. The fungal to bacterial ratio is definitely what we're looking at. Just like that chart that you all saw from Patrick's presentation, that's what we're looking for. And I like to look at predator prey as well, because that'll show you that there's higher trophic level species than just bacteria in there.
Great. And just as a reminder that soil health tests are reimbursable for Star Plus participants, so they can submit the cost of this as for their reimbursement.
Thank
In
you
the
for
reimbursement
saying that,
package.
John. That's while you're here, I wanted to ask you a couple of clarifying questions, or I guess just bring it out for the group. Is that that was something that I kind of brought up in my area too, was like, I want more testing. And John said, well, then go get more testing. That's totally acceptable and allowable. And that's what you should use this money for. So if that's what you guys feel is important, then go do that. And so I would recommend doing more biological testing, and I would also recommend doing more of the field testing. Go out there and do infiltration tests, and especially infiltration tests and compaction tests. There's like, that doesn't take much, and it would be so beneficial if all of your producers had that information. And we also, all of us had that across the state to compare. And then John, can you also clarify for if somebody wanted to use the STAR funding for compost application, that can cover trucking, the actual cost of the application of like the operator to do that up to a certain amount, and then the product itself. Is that correct?
Yes, it is. All those things are correct.
And the same with the extract. I know that people in our area have already applied and received the funding for that. So that's all
Yes.
acceptable too, right?
That's also reimbursable. And we're gonna have to keep moving here. We have one more speaker,
Thank
and
you.
we jam-packed this one.
Oh,
But
I'm sorry. Okay.
no,
Thank
you're
you.
fine. This has been great. It's been a really packed schedule though. So last but not least, we're gonna have Christine Newton, who is a agronomist with the NRCS, and she's going to speak about the NRCS new soil carbon amendment practice.
Okay, can you guys hear me?
We can.
Okay, perfect. All right, so yeah, I'm going to talk about one of our conservation practice standards, Conservation Practice 336, Soil Carbon Amendment, of which compost is an excellent option for the implementation of this practice. I wasn't entirely sure who the audience was going to be, but I was going to give an overview of how our conservation practice works and what are the goals of our conservation practices. So NRCS has approximately 170 or so different conservation practices, many of which are going to be implemented in STAR and STAR Plus. And what these practices do is they basically provide a level of consistency across the nation as well as within the state. So when we say, this is what nutrient management means, or this is what soil carbon amendment means, there's some level of consistency from here to Nebraska to Pennsylvania and so forth. It assures environmental compliance. All of our conservation practices have gone up on the Federal Register, have been open to public comment, and have had a categorical exclusion when it comes to our environmental analysis requirements under the regulations. They're based on science, not any sort of programmatic funding. And we try to keep them current. The goal is to review and revise them on a cyclical basis. So about once every 5 years, these practices are looked at, they're put back up onto the Federal Register for comment and so forth, to try to keep them up with the latest technology and research. And then all of our conservation practices are sent out at the national level. So there is a national standard, and then the states have the opportunity to supplement to fit their local conditions, comply with any state laws that might be required. So all of our conservation practices are identical in their framework. These are the parts of the conservation practice. They're all named. They have this 3-digit code assigned to them. They're defined on a unit basis. So soil carbon amendment would be applied on an acre basis. They're defined. They have the purposes to what we're trying to achieve when we implement the practices. a condition where practice applies. Sometimes our conservation practices are only applicable to a certain land use. We'll learn that CPS 336 is open to all land uses with some caveats, but then there's this meat and potatoes part of the standard, which is the general criteria. And these are mandatory criteria. Basically, you read through them and you find out what it means to say that the practice is fully implemented. So what is the practice standard? It defines technology. Again, it identifies those purposes and where they're applicable. Really, we look to that criteria to say when and how the practice is implemented. And then it has these sort of installation and operation and maintenance requirements that are tied to it as well. Where do we find our conservation practices? They're all on the field office technical guide. So you can just Google NRCS FOTG. You can key in onto your state, because if you remember, states do have the options to add supplemental information. With CPS 336, it's pretty identical to the national standard. So there's not going to be too much deviation, between ours and Kansas's or Nebraska's or whatnot. But I still say if you're implementing the practice within Colorado, that you drill down into the state and then find our specific state standard. So what does this have to do with STAR and STAR Plus? Well, because the majority of the initial funding to kick off the STAR and STAR Plus program comes from federal monies, there's this requirement to implement practices that are categorically excluded from having to undergo a separate environmental analysis, or what we know as NEPA. So basically, we're just saying that because we're using these taxpayer dollars, we've already gone through that process to make sure that these practices, how are they going to impact our special environmental concerns like cultural resources, T&E species, wetlands, etc. So because those monies are federal, we just have to make sure that we're following those standards. And again, all of these conservation practice standards have undergone public comment and spent time on the Federal Register. So that being said, all of us are taxpayers and members of the public. If you don't like something in the standard, we do have the opportunity to comment when the standards go up for public comment on the Federal Register. So now finally getting into 336, the soil carbon amendment. How NRCS defines soil carbon amendment is basically the application of a carbon-based amendment derived from plant materials or treated animal byproducts for one of these following purposes, of which many of our presenters already talked about. This is why we are applying compost and compost extract. So what we would do is select one or more of those purposes and try to adopt the criteria that's outlined for each of those purposes. Here, this is just a summary of some of the key points that are within that general criteria. Again, that criteria is mandatory for us to say that the practice has been implemented to the standard. The first big thing is that there's got to be a soil test prior to the application of a soil carbon amendment. We do require that it's sent to a lab that participates in the North American Proficiency Testing Program. It's essentially just saying that this lab subjects itself to like blind quality control. So soil has to be tested prior. The amendment also has to be tested for required parameters that are outlined in the standard. And that's going to depend on what type of carbon amendment you're going to be putting on. Since we're focused on compost, I'll stick with that. But we also put on biochar, compost, a compost biochar mix. And then we also have a category that's just other carbon amendments as approved. It does tie into one of our other conservation practices. It's typically only going to be an issue when we're using animal-based compost at a higher rate. But basically, we're saying if the product that you're going to apply based off the rate that is recommended, if there's going to exceed 100 pounds of nitrogen, we're going to require that we're budgeting those nutrients to make sure we don't create a water quality concern. Do not apply high salt materials where salinity is a concern. So I think the cutoff is 8 millimeter or I don't know what that exact unit is. It's in the standard, but if you're in an area with a salinity concern and we're using an amendment that is high in salts, just either switch to a different amendment or just look at a different field or whatnot. So in the new Conservation Practice Standard 336, it is applicable on all lands. We tend to not allow it on rangelands except when it's facilitating a seeding practice, or if it's just a really marginal area. It's low in productivity, bare ground, really weedy. That's typically when we're going to apply it on rangelands. And then if you are applying, we try to limit it to just, broadcast application, especially when we're working on native rangeland. We don't want to encourage subsurface application or any sort of incorporation of that compost. So again, we have many different types of carbon-based amendments. Biochar, compost far and away is the most popular soil carbon amendment that we use on an NRCS side of things. And then what's becoming really popular is kind of mixing biochar with compost. I think that helps with some of the economic feasibility. But also inoculating biochar with compost tea is also